when we rotate, we need to have an angle that's less than 180 degrees. And so this 300-degree angle right here, if we subtract that from 360, we end up with a 60-degree clockwise. Or the 240-degree angle, too big for our protractors, if we subtract it from 360, we end up with a 120-degree angle, which you can do. So that's the idea. Okay? Now, there are kind of like rules here for rotations around the origin on a coordinate plane, okay? So for example, for a 90 degrees counterclockwise rotation, we're going to do xy, and then that becomes just negative yx. So you can see that the x and y flip, and the y becomes negative. There's a rule for the 180, there's a rule for 270, there's a rule for 360. Now 360, if you rotate something 360, where does it end up? Yeah, the same exact spot. So it's kind of silly that they did this, but here you get it. XY goes to XY. Whoa, mind blown, right? Okay, so anyway, we're not going to worry so much about memorizing these things. I think it's like, how many of you guys actually like to memorize stuff, right? Taylor does? All right, so Taylor, if you want to, absolutely go for it, okay? But if it's for me, memorizing mathematics was not very fun. I believe that most of you guys feel the same way. And so instead of trying to memorize all of these, we're just going to use the same skills that we've been using with our patty paper, okay? And it will still work, too, which is really handy, okay? So, looking here, okay, for example, A, we're being asked to take quadrilateral ABCD and rotate it 270 degrees. Now, we're not given a direction. But remember, if you remember, we just were told earlier that when no direction is specified, you can assume that a rotation is counterclockwise.
Why is that? Why can't it be automatically clockwise?
You know, that's a good question. I want to think that it's because, you know, like I think, and I this could be wrong, but I feel like I remember reading that, like, in Great Britain, most of the stuff that they do is clockwise. Like, they assume things are clockwise. So, for example, horses run clockwise around the track, but then in America things run counterclockwise, and it has to do with the fact that like we rejected their system. They drive on the left-hand side of the road over here. We drive on the right-hand side of the road over here. Okay. Well, sometimes, right? So I mean, you know, they were our imperial overlords, and we, you know, rebelled against them and stuff. So we're like, well, we're gonna ride on the right-hand side of the road. Take that, you know. So, but anyway, so. I don't know if that's true or not, but I think that's why I don't know, that might be wrong. I have to take a look at that and see, but I feel like I remember reading that, yeah, so anyway. It's a fun story if not, right? Anyway, so, we want to take our triangle ABC, or not triangle, quadrilateral ABCD, and rotate it 270 degrees counterclockwise. That means this direction. Okay, of course, so we could use the 270 degree rotation counterclockwise transformation here. We could do that. Okay, coordinate notation. But instead, well, in fact, you can see it actually done here for us. Okay, actually, let's just go ahead and look through that. So the rotation image of xy then becomes y negative x. So you can see they listed out A, B, C, and D, and then they did this 270 degree transformation. So they swapped the x and y, and they made the x, the y coordinate there negative. Okay, so they swap, x and y swap, and they make the second coordinate negative, or opposite, I should say. So 0, 2 becomes 2, 0, but a negative 0 is still 0. 1, 4 becomes 4, and then negative 1. 4, 2 becomes 2, and then negative 4. And then 3, 1 becomes 1, negative 3. Okay, like that. So all the y coordinates are opposite of what they should be, and then just swap them. Okay, and so if we then go ahead and plot this, let's go ahead and plot here, A prime, 2, 0. Okay, B prime is 4, negative 1. C prime is 2, negative 4. And then D prime is 1, negative 3. Okay, and then go ahead and we'll connect those dots too. Okay. So it went 270 degrees counterclockwise there. Okay.
Can you write the words instead of the arrows? Like, this is really CCW.
Yeah, you can write CCW there if you want. Yep, exactly right. That's fine. Okay. So now, Kyle, instead of going 270 degrees counterclockwise, what other way could we have rotated there?
30 degrees clockwise.
9 degrees clockwise, exactly right. So if I show that to you here real quick. Oh, what did you say?
That's 30.
Oh, 30, okay. But again, what's the math we have to do to figure it out?
You gotta do 360 minus 270.
Listen up, please, guys. Shh. 360 minus 270, exactly right. Okay? So right, that's equivalent to doing a 9-degree rotation this way. Okay? And let's just check then to see if that is in fact a 90-degree rotation. If we look here, for example, we're rotating about O, the origin, and let's go ahead and just draw a line from O to A, and check our rotation there. So if I drew a line from O to A, where must I also draw a line to? From O to A prime. Okay, you always have to match up your points. And does that look like a right angle there?
Yep.
Yeah, absolutely. We don't even need to measure that. You can clearly see it's a right angle there. Okay?
Yep.
Like the formula, because that's too difficult.
Do you want to just use the formula?
Yeah.
Yeah, that's fine if you'd like to, okay? I prefer to only, I've memorized as little as possible because I don't like to memorize stuff. So that's why I just use the patty paper still.
So for the angle part,
Shh. Sorry, hang on.
for the angle part, you subtract.
Yep, 360 minus, because again, 270 rotation won't work on our protractor, so we got to subtract from 360, go the opposite direction. So instead of 270 counterclockwise, we'll do 90 clockwise. Okay, so here's one for us to try now. Letter B, let's go there. Page 91, sorry. Page 91, guys and gals. Okay, and so we're going to do this here, and then we'll just check it using our patty paper. So we'll go ahead and do the coordinate notation stuff, check it with our patty paper. But if you guys want, you can totally just do this with your patty paper instead. You don't have to actually use the coordinate notation stuff if you don't want to. Page 91, page 91. Okay? All right, so if you look here, all right, so Evan, I'm going to have you help me with this. So we want to rotate triangle KLM 180 degrees. All right? The rotation image of XY then is what? So, Evan, if we go back to our table here, if we're trying to rotate 180 degrees, what does it tell us that XY, the point XY here, becomes? Exactly, so we have to swap the signs. So, positive x, positive y becomes negative x, negative y. And so therefore, Evan, 2, negative 1 is going to become what over here? Shh, hang on, let him do it, please. Sorry. Negative 2, careful. There you go. It's opposite, so negative 2, positive 1. Okay, I see what you're saying, but if your y is already negative, then a negative 1 becomes a positive 1. Because there's two negatives.
Wait, why is it negative x and negative y?
All right, shh. Guys, look, I need the talking to stop. Whatever's going on here, goofiness needs cut out. Listen up, please. There are good questions you guys need to be listening for. All right, so first of all, Evan, does that make sense to you?
Yeah, that makes sense.
Okay, so Evan, what's the next one going to be then?
-4 positive.
-4 positive 1, and then the last one here. Very good. Okay, Kyle, now you had a question?
Yeah, wait, where did we get the negative x and negative y from?
So if you look back here at your table,
Okay.
they've already kind of described for us what happens when you do a 180-degree rotation.
Oh, okay.
It takes your normal xy point and goes to negative x, negative y. How do they know that? Well, it's because they did the rotation using our normal method, like of patty paper or whatever, and they saw that this was the pattern or the rule that shows up, okay? Do you need to memorize that pattern or rule? No. If you're comfortable using your patty paper to do a rotation, do the patty paper rotation. But we're doing it this way because we have it here, okay?
So if you were to use your patty paper, can you show us how to do that?
Yep, absolutely. So here's one thing I want to point out here. So remember we have quadrants in the coordinate planes. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4. And it asks us to predict the quadrant in which the image will lie. Okay? Triangle KLM lies in quadrant 4 right now. If we're going to rotate 180 degrees, all right, if we're going to rotate 180 degrees, Garrett, where do you think this is going to end up? What quadrant will it end up in if we rotate it 180 degrees? What quadrant do you think it'll end up in? Quadrant 3 over here? Okay, so maybe 3. We're thinking. Okay, let's see here. Let me pick someone else to check. Chardez, where do you think it'll end up? Do you think it's quadrant 3 as well? If we rotate 180 degrees? Okay, 3. So that's 2 for quadrant. Well, I'll just do that. So maybe quadrant 3 still. Okay, anyone have a different one? Yeah, Josh? Quadrant 3 as well? Oh, 2. Zaria, you 2? 1, okay. 2. 2. Okay, so anyone say 4?
Yes.
Really? Krishna? Okay, I was going to say.
I mean, it's kind of simple. I know, like you're supposed to predict, but if you just take the first point, I mean, you can tell if it's wrong.
We'll take a look here, though, and see. Listen, please. Okay, so we could use our rule, because right here we used the rule, we figured out our points. This is one way. We could go ahead and plot these points right now, and then get our shape. Or, I'll show you how to do it with the patty paper real quick, just to make sure we know how to do it, okay? So again, our point of rotation, what do we always rotate about when we're doing rotations in the coordinate plane? 0, 0, or the origin, exactly right. So I'm going to put that point right there. Okay, so now to do this, remember we do the same thing as we normally do. So I have to draw a segment from the origin to one of my points. So let's just do it to K, because that's the closest. Shh, too much talking. Ramel, where's your book? Get it out. Skylar, I'd like you to get your book out too. I know you're not feeling well, but at least you can follow along. Okay, Ramel, come on, book out. This is like ridiculous. I have to say that to you. Okay, book out. Does anyone else not have their book out? You should. Okay, should be following along. All right. Connect the dots. There it is. Okay, now I want to do a 180-degree counterclockwise or clockwise, doesn't matter, right, rotation. So there's a 0, clockwise is over this direction, so I'm just going to go like that.
Wait, what? How do you do that?
180 degrees.
You just went really fast.
Look, there's my segment. I can measure 180 degrees. Well, 0's right here, so 180. It's the other side of the protractor.
So mine doesn't have a hole in it. Mine's gonna
So yours is same principle, right? Yeah, it's going to be a straight line. So you just put your center of your protractor there, and then 180 is over here. So you put a little mark, and then you draw out to it. That's all. 180 degrees. Yeah, right past.
So mine's gonna go like through my grass. Is that okay?
It could end up doing that. Yes, it could end up doing that. Yes.
So we were right with number 2?
Yes.
Yeah.
Yeah. Okay, so here we go. I'm going to use my patty paper again. I'm going to scratch out this old stuff I got on there. And we're just going to do our normal thing of copying our point of rotation, copying our 3 vertices of the triangle. Okay, and don't forget to draw your little thing. I'm just going to freehand that. Perfect. Okay, and then I need to draw on the backs of those points. So on another part of my paper, I'm going to draw on the backs of those points. Oops, oh, that's okay. Okay, so I draw on their back. So I line it back up here once more. There it is, lined up. We just rotate around point O, around point O, around point O, and there it is, lined back up. And I'll draw on the backs of those. Okay, you can barely see them, but it's this point, it's this point, and it's this point, and then reconnect those dots. Okay? So let's rename our points here. So what's this point's name going to be?
That was going to be M prime.
M prime. This one will be?
K prime. Oh, no.
It's L prime, yep, and then it's K prime. Okay. Now, check it out. Let's check our work. K prime, we were supposed to have a coordinates of -2, 1. Is that true? Yeah. -2, 1 checks out. Okay. -4, 1 for L prime. -4, 1. That's right. And then -1, 4 for M prime. So check, check, check. They all work. And so it is quadrant 2 where it ends up. Okay, quadrant 2. So good job to everyone that predicted quadrant 2. Okay? Questions on any of that?
I didn't do it that way. I like quads. I mean, I like got the points first.
You like doing this right here?
Well, I like them the other way, but it's good.
So either way, really, either way you do it is fine. You can use the coordinate notation way, or you can do it using your patty paper. Either way is fine. I just want to show you that it does give you the same thing. Again, for me, I'm not going. You guys aren't going to have. I'm not going to give these to you on the test or a quiz. You will need to know those if you choose to use them, or you can use your patty paper. Yeah, that's what I was saying. Otherwise, you have to memorize, right? Okay. So let me have you guys try one here. Number 7. We're just going to do We'll just do one of them here. So go ahead and try number 7 if you would on the next page 92. Try number 7, please. Try number 7. Okay. Draw the image of the figure under the given rotation. So number 7, please, on page 92. Go ahead and do that if you would.
Wait, where do you put point P at?
So, point P, you're saying?
Well, must be.
Our rotation point is always the origin. It's always the 0, 0. Always around 0, 0. Yes. Yes, exactly. Guys, and just in case you didn't hear Haley's question, it was a good one. If it doesn't say which direction to rotate, we always assume counterclockwise. Okay? So go ahead and try that. Number 7, please. It's always counterclockwise. Always counterclockwise. Sorry. CCW. We're rebelling against the British Empire. Okay. Shh, Derek, Jason, whoever's talking. It was not Jason. It was you, Derek, for sure. You were someone else you were talking to. Let's get started, please. Talking about getting your work done. Let's do that, okay? If you need to extend the line, yeah, extend the line. What do you need to? So we're doing number 7 here, okay?
We're doing patty paper, I'm guessing.
You may use patty paper or the coordinate notation, whichever one you choose.
Wait,
No.
One second, Jason. You have a question? I'll be back.
yeah, I got one.
All right. One moment, please. Okay. Right back there, Jason.
Just X and Y flip, and then Y becomes the opposite of what it was. So 2 negative 1 becomes, or 2 positive 1, sorry, becomes negative 1. Yes. Trying to rotate me? Okay, so let's see here. So you got it, copy, that's good, okay? So now remember you can draw an actual angle here of rotation. So you're gonna put your protractor down, as you normally do, right? Like you did like here, for example. You measured it, right? Now we're gonna actually draw the angle line of our segment. Okay? Right? Like this is what we're gonna use. It's gonna be one side of our angle of rotation. Remember, an angle has 2 sides to it. So it's gonna be the one side, like this. And we have to measure not 80 degrees here. We want to measure 90 degrees. So we're gonna set it down, so it's lined up, and then measure a 90-degree angle on your protractor. I'll hold it and go ahead and measure a 90-degree angle. Okay, perfect. Now we're going to use our straight edge. And draw. Okay, so there's a 90-degree angle we just drew. So now we can take this and rotate it. Still keeping our origin. Now it's lined back up. And now you can plot this point.
Let's go picture.
Except now this point is like
Catfish. Catfish.
yeah.
Remember we did that last time when it was like
Is this
before
right here?
Are you gonna work?
Okay, there it is, right? So when it rotates, the point
Feel a
goes
little
there.
bad to have
Put your paper over to the point transfer. Don't flip it over. You flip it over, that'll take it, draw that back there, then you gotta make sure you go back. That's how it should be. So again, lines up.
Honestly,
Like that.
that's why you're at work. That way you...
Well, 180 would be like, there.
Or just take smoke them home before you go.
So you, yeah, you show our name. So again, we show you here, you're from there to,
It's a wobbling one.
90-degree angle is right here.
You can go, yeah. Talking about you can go pick up those. Or you can go to my house after you've done one day and just
On this side of that. I'll go do it up here again. All right, guys, let's listen up.
no, dude, we didn't say out all.
All right, I'm going to go over right now, okay? All right, here we go. Let's listen up. Okay, so I'm going to do this one here. I did it using the coordinate notation, okay? Listen up, please. I did it using the coordinate notation, but I'll show you how to do it using the patty paper, okay? So, again, and I think this gets a little more confusing because there's so many lines in here and stuff like that, and there's the y-axis and the x-axis, so it's a little bit difficult, but it's just like what we did before, okay?
Oh, wait,
so
I have a
remember,
question.
all right, hang on. I'm not
Counterclockwise
taking,
or
no taking
counterclockwise?
questions, no questions right now, okay? Listen up. I'll ask for questions later.
I just need a simple question.
Okay, I'll answer it in maybe a little bit here, okay? So here's our triangle, okay, and here's our center of rotation, okay? So we always draw a segment from our center of rotation to one of our vertices. I drew to P because that's the closest one. Doesn't matter which one you draw to, right? And so why do we draw this? What's the point of this? Shh, guys, over here. Cool it. Thank you. Okay? No, you need to say, wait, because you had a question, and I'm going to answer it here in a second, okay? So we drew this segment. This is one side of our angle of rotation. Remember, angles always have two sides to them, right? Okay, there's like one side here, okay? So this is one side of our angle of rotation. That gets us started. That gives us a place to put our protractor. Okay, I got to align my protractor. I'm going to center it on the point of rotation, and it's got to line up with one side of my angle of rotation right here. I want to rotate 90 degrees counterclockwise. So from 0, I'm going to go up to the 90 right there. Okay? And then I'm going to draw from my center of rotation to that 90-degree angle. Now notice which direction did I go here? I went counterclockwise, because if it doesn't specify what direction, we go counterclockwise.
Huh? It doesn't-
Counterclockwise if it doesn't specify direction. Okay, so take your patty paper at this point, right? I'm going to scratch out my old work here.
How is it going sideways if it's a 90 degree?
Say it one more time.
How is it going sideways if it's 90 degrees? Can it go straight up?
9 degrees on the protractor. Again, if I line up my protractor with one side of my angle of rotation here, 9 degrees is right here at the top of my protractor, right? So that's a 90-degree angle that I just made. So is that what you're asking about, Jaden, there? That's a 90-degree angle. And then we take our paper. See, I'm going to try and squeeze this in.
Hey, I got it.
Okay, point of rotation, vertices. Okay, and then go from O to P, or P to O. Oh, this pencil's not going to stay put. Okay, and then we rotate it. And you can see Ramel, Derek, please stop talking. We're going over things you need to be paying attention right now. I want you to face forward, Ramel, so you don't talk to Dominic, okay? Who are you talking to then? You were talking, okay? I don't care. You were. I heard stuff coming out of your mouth. Face forward, please. Ramel, I don't know why you're arguing. Face forward. Legs underneath your desk. Whole way. Come on. Oh, come on. Come on, face forward. Let's go. Please don't be this way. Thank you. Thank you. Okay? Here we go, guys. All right? We're going to rotate. All right? This shape. There it is. This is where it should end up. These are the points right here. All three of them. Okay? I'm quite lined up right. But there you go. Okay? So, again, these won't transfer unless we draw on the backs. You got to flip your paper over and draw on the backs. Okay?
May I ask why you're doing that with the color?
Because this is the only pencil I have up here right now. Okay?
What I do with that, I just press really down on my paper, but it doesn't go through, I know it doesn't go through the front, but it makes the indent a little indent.
There you go. If that works for you, unfortunately, no one will be able to see that up here if I did it that way. But if that helps, do it that way, okay? Okay? Shh. All right, and connect the dots. Connect the dots. And then you've got your shape. Okay, that's what it should look like.
Oh, wait.
Shh. Guys, again, with the talking, cut it out. Kyle, Matt, thank you. All right, getting sick of it. Here it is, rotated. I have all these people with questions, and then when it comes to, time to actually pay attention and learn this stuff, and then no one's paying attention. Or not no one, but a lot of people aren't, okay? You need to be listening, okay? This is going to be on the quiz on Thursday. You need to know how to do it.
Won't be here.
Won't be here. Well, still, other people will, okay?
Wait, when am I going to take this quiz?
I don't know. We'll figure that out when you get
Okay.
back, okay? But, yeah, we'll see. I might just, we'll see. So there it is, anyway, okay? Boom. There's your rotated triangle, 90 degrees counterclockwise, okay? Any questions on that?
Nope.
All right, real quick, I just want to make sure we understand. We're not going to do number 8, but number 8 says to rotate 270 degrees. So a 270-degree counterclockwise rotation, we can't do on our protractor.
90 degrees.
But we're going to do 90 degrees clockwise. So in fact, when you're doing a problem like this, you can even cross it out and just put 90 degrees clockwise if you want to, okay?
So you rotate the opposite way?
Looks good. So it rotates, not counterclockwise, but clockwise. So that looks, let me see one more time. Yeah, I think that's right, okay, but what you have. Okay.
Alright,
So,
I tried really
here's what I want you to do, okay? From your homework from last night, okay? From your homework from last night, I want you to work on some problems here, and we'll call it a day with that.